So we have some interesting patterns in this set of equations here. You can see the first equation, y is equal to mx plus c, is a straight line equation. So let's call this equation a linear equation here. So this is called a linear equation. Now the next equation, ax squared plus bx plus c, is called quadratic. So this is a quadratic equation. The third one, ax cubed plus bx squared plus cx plus d, is a cubic equation. So we know this is called a cubic equation. And the fourth one, ax raised to 4 plus bx cubed plus cx squared plus dx plus e, is called a quartic equation. And so on. So the next one will be ax raised to 5 plus so on, is called a quintic equation. And then, so you can just keep writing equations like this. But can you observe a pattern there? Now you can see the first equation, y is equal to mx plus c. You can see that mx plus c is the same as bx plus c. Now you can look at the terms here. Now this equation quadratic, that is ax squared plus bx plus c, has two parts in it. Ax squared is quadratic and bx plus c is linear. So when you add these two together, your final result is going to be a quadratic. Let's do this in the graphical part. First, let me explain all this here. Look at the next equation. I have ax cubed. Ax cubed is cubic. So this part is cubic. Bx squared is nothing but your ax squared. I am only changing the alphabets there. So x squared term is a quadratic. Cx plus d is again linear. So I have three parts. I am adding a linear equation with a quadratic, with a cubic, and my final result is going to be a cubic. Look at the next one. I have ax raised to 4, which is a quartic. And then I have a cubic relation, bx cubed. And I have a quadratic, cx squared. And then I have a straight line equation, that is linear, dx plus e. So when I add a straight line with a quadratic, with a cubic, with a quartic, my final result is going to be a quartic equation. Now let's look at all these equations graphically. Now I'm going to use this graphical tool, and so let me enter all these equations. So the first one, let me take y is equal to mx plus c. So let's take some constant there. Let's take some y-intercept. A very simple expression, x plus 2. So when I say y is equal to x plus 2. Now this is a straight line equation. So this is a straight line which passes through, you can see the y-intercept there. So it cuts the y-axis at 2. That is 0, 2. Now you can say I am going to take a very simple quadratic curve. What is a very simple quadratic curve? X squared. So let me take y is equal to x squared, and you will see. So this is a perfect quadratic curve. And what is going to happen if I add x squared with x plus 2? That is, I am going to add a straight line and this curve. What is my final result? Let us take some values of x and then find out the corresponding values of y in this linear expression, y is equal to x plus 2, and in the quadratic curve, and what happens if I finally add both linear and the quadratic together. Okay, so let's take x to be minus 2. Let's take very simple values, or say also take minus 3. Start from minus 3 here. So when x is minus 3, you can look at the straight line relation here. So x plus 2, therefore y is equal to minus 3 plus 2. What is minus 3 plus 2? It's going to give you minus 1. So you can look at this relation here. So this gives you, I'll put a point over there. So this is minus 1. And what happens when x is equal to minus 2 for a straight line? Minus 2 plus 2 will give you 0. And what happens for minus 1? So minus 1 plus 2, that will give you plus 1. So that straight line has this coordinates here for x is equal to minus 1. And what happens for x is equal to 0? You know the y-intercept is 2 here. And for x is equal to 1, that is going to give you 3. For x is equal to 2, that is going to give you 4. And for x is equal to 3, that is going to give you 5. Now these are all points lying on the straight line. Okay. So I've just taken values like x is equal to minus 3, x is equal to minus 2, minus 1, 0, 1, 2 and 3. And I know the corresponding values of the straight line equation y is equal to, so it starts with minus 1 and then this becomes 0 and this is going to be plus 1 and then this is going to be 2. For 1 it is going to be 3 here and this is 2, 2 plus 2 is 4 and this is 5. Okay. The next part, y is equal to x squared. Now if you look at y is equal to x squared, if you plot all the points, you can see for minus 3, y is equal to x squared. It is minus 3 whole squared. So that is going to give you 9, plus 9. Okay. And for minus 2, you're going to get it as plus 4. And for minus 1, it is plus 1. And for 0, it is 0 here. And for 1, it is going to be 1. For 2, it is going to be 4. And for 3, it is going to be 9. Okay. So this has values like for y is equal to x squared, when x is minus 3, this is going to be 9. And this is 4. This is 1. This is 0. And this is again 1, 4, 9. You can see the values repeat again. And therefore, it is symmetric about this y-axis. What happens if I add all these? Now if I add x plus 2 to x squared, now you can see if I'm going to just add these two terms. So 9 plus minus 1, so that is going to give you 8. 4 plus 0, that is going to give you 4. And 1 plus 1, that is going to give you 2. 0 plus 2, that is going to give you 2 again. 1 plus 3, which is again 4. 4 plus 4 is 8. So you can see the values repeating again and again. Something like this. Something like your quadratic. Okay. Now, when you plot it, that is, I'm going to add, let me do this here. Now let's graphically add these two values. That is, let's first place these points here. That is for x is equal to minus 3. If x is 3 here, minus 3 here, you're going to get a value, say 8. So you will get it somewhere here. Let me put a point there. And for x is equal to minus 2, you're going to get it as 4. And then for x is equal to minus 1, you're going to get it at 2. Okay. For 0, again I'm getting it at 2. And for 1, I'm getting it as 4. And for 2, I'm getting it as 8. Now let's plot this. Now when I say I'm going to add x squared with x squared added to x plus 2, you can look at the final resulting graph that passes through all those points here. It's quite interesting, right? So therefore, when I add a linear expression with a quadratic, my final result is also quadratic. Now let's take a cubic equation. So what is cubic? X cubed. So cubic equation looks like this. Now when you add a cubic expression with a quadratic, so I'm going to add x cubed. So let it be x cubed here. Now if I'm going to add x cubed plus x squared, and you can see the final result is still cubic. I'm adding x squared. You know what is x squared? X squared is quadratic. So I'm just adding x cubed with x squared plus a straight line. So I'm going to add x plus 2. You can see the final result is also a cubic. The only difference is there is a slight shift. Okay. So here you get an idea when you add a straight line with a quadratic with a cubic, your final result is a cubic. And it happens for all the other relations as well. So when you add a straight line with a quadratic with a cubic with a quartic, your final result is going to look like a quartic expression. When you come across equations like this, start breaking this equation into smaller parts and start visualizing it.